In this video, I will show you how to bring lesion masks into a template space within the LESYMAP package, so later you can perform lesion to symptom mapping. This information that I'll give you here, it's also partially on the LESYMAP page. If you go at the end, you can see the documentation, and there is a wiki page which explains how to perform registration of the lesions in template space. Well, before starting, I need to explain you why do we need to register these lesions in template space. Suppose you have a single stroke subject, a patient, and the MRI image looks like this. This is the ITK SNAP program, and you can see that there is some kind of damage here on the left hemisphere. This is a radiological orientation, so the left is on the right, and there is some lesion here, and you probably should have by now also the lesion mask manually drawn. So let's drag in the lesion masks so you can see how that looks. So the red part here is the lesion mask, and if you see the label here, the segmentation, that's the value of the voxel in there. All the red voxels have value 1, and if you go out of the voxel, the label, the value of the voxel is 0. So all that this file is a binary file with 0 and 1 voxels. And you can see how this lesion goes around for this subject. Now, the problem is that each subject is in a slightly different space, and you want all the brains from all the subjects to be all in the same space, so you know that a certain voxel in an area of the brain corresponds approximately to the same region in the brain, approximately to the same gyrus or sulcus. And to illustrate this, I can actually drag and drop on this very same image the template file. The template file, if you look at it, it may look something like this. This is the MNI 2009C template, ICBM, and it looks something like this. So we want everything to be in this space. But if I drag and drop this template on the image of the subjects that we just saw as an additional image, we can see that they are not at all in the same space. We can also overlay them, display as overlay. So you can see that they are not at all overlapping well. And if you go to let's make this again a base layer, and if you check where is the segmentation, now our subject is in the right spot, but on the template is a completely wrong spot. So what we need to do is bring this lesion mask file, in this template space, and to do that we will register the anatomical image of the subject on this template space. So that is done in LESYMAP with a single command. Now let's close this, and I'll open an R instance here. So this is RStudio, and I have already loaded LESYMAP, downloaded and installed it. So to register the lesion mask in template space, all you need to do is use a single command, and that command is register lesion to template space, to template, which is this one here. So essentially you can also write register lesion to template, and you'll see this help with all the detailed information of the arguments that it takes. Now, how do we perform it with an example? Let's suppose we have a single subject with these two files. So we can first define two variables, one for the anatomical, which is this T1 image, and one for the lesion mask, which is this lesion one. And let's say we call this let's say MRI equal, and you can define here the path of the file for the MRI image, the T1. In this case, I'm already located in this folder, so if I type in T1, I should be able to autocomplete that. And for the lesion, we can say lesion equal to lesion. Hold on, we need to define this as a character. And now we have defined two of these variables, the MRI and the lesion. Once you have done that, of course, you need to make sure that you have called the LESYMAP. You have loaded the LESYMAP package. So we do that again, just as an example. And now you can simply call register lesion to template. We'll save this in all the output in a single variable called lesyreg, and we can make register lesion. We can actually also autocomplete this, and we can start defining the arguments. So sub image is actually the MRI that we defined. Sub lesion is actually the lesion variable that we defined. All you need to define is these two arguments, the sub image and the sub lesion. And by default, you can already run the function and you'll get a beautiful registration. The only thing that I advise is that you output actually the results on a folder somewhere. And for this, you can define out prefix. Out prefix defines the prefix of the files that will be saved on the drive. And you can specify full path, let's say data folder, blah blah blah, or you can specify just the prefix itself. So if I do this, out prefix equal to reg underscore, what the function will do is produce a series of files, all with the prefix reg underscore in the same folder. And once you run this command, all you'll see, I have run it before, so I'll show you only the result now, because it takes quite a while, is actually this output here. So you see I've run this command and the function will start to work. If you don't define a template of your own, and you can define a template of your own, then LESYMAP will just use the provided template, the MNI 152/2009C template. It will also show you the path where that template is located on your computer. Then it will load these files, the MRI and the lesion that we have specified here, and we'll start to do the other steps. One thing that I want to mention is that these variables, the MRI and the lesion, I have defined them here as file names, but you can also preload them and have them as ANS images. So for example, I could have done something like this, ANS image read, and I could have already preloaded them in the memory, and then just called the same exact lines here. So once these are loaded down here, you can see that there is a check being performed that the lesion and the MRI image are in the same space, just in case you have done something fancy on another software or anything like that. It will start to perform some processes on the MRI image. It will perform a bias correction. It will denoise the anatomical, sometimes in particular older images and MRI images obtained from scanners of 1.5 Tesla have some noise in them. I can show you that in a minute. And then it will start to perform the skull stripping. Skull stripping helps a lot because once the skull is removed and only the brain is left there, you can do a brain-to-brain registration. And this will help a lot to get the gyri in the same place, without the registration being affected by the skull itself. If you leave the skull, the registration is still going to be decent and good, but the skull will take a toll, let's say, in the outcome of the registration. So we're performing skull stripping here, and then you start to see these warning messages. I left them there. Sometimes for some images these warning messages start to appear. Before in NSAR it used to be something like bad det. I believe it's bad determinant. Now I've seen this new image. There is about 15 of these. And these appear because when we call NSAR underneath to perform the brain extraction, there is a function ITK multi-start optimizer that has some problems with it. Actually, I have not seen any real problem in the outcome, but you may see these warnings. Don't be afraid. Then what will be performed is the template registration itself. At this step, the MPR of the subject is registered on the template, both of which are brain only at this point. And then the registration parameters that are obtained from this step are applied to the lesion image to bring it in the template space. You'll have a couple of information, descriptive information, what was the lesion size before, what is after the registration. Typically there is a little bit of a growth of the lesion size, and it will show you how long this took. I have tried this on my laptop, which is a Microsoft Surface i7 with 8 gigs of RAM memory from 2017, and this takes about 1.3 hours. Now beside that, the step that takes the longest part is the registration itself, and this takes about an hour, as you can see here. But there is considerable time also between the from the skull stripping, which if you see the hour here is 1836, and then it's the next step starts at 1850. It takes about 15 minutes also to skull strip the image, but the results are worth the wait. Okay, so you have performed all this registration and now you want to see the results. And I told you that if you specify the output here, you should see a bunch of files on the side. And let me show you that result, what you'd see. These are the files that are produced by the registration. Actually, let me just copy also these two files that should have been on the same folder. Okay, so this would be the folder after you run the registration. The only file that you are really interested in is this one, sublesion template. This is the lesion in template space. And if you want to see that in template space, you can just open the template. Let me just open this template here and go back and drag in this lesion, the template space. Now this lesion mask is roughly in the same spots, in the same area where it was in the subject. And probably you can go ahead at this point and start to do your analysis, your lesion to symptom mapping study. But I'll just explain to you a couple more things. There are several other files here. Some of these are the registration parameters itself, so this warp, the inverse warp and the warp itself and the mat. You can use them later to move the subject from and to the template space. But you can also investigate the quality of the registration. And to do that, you can just drag this sub-image template into the template space to see how well it matches. So let's do that now. As an additional image, sometimes the image is dark, so we can just right click an ITK snap and auto adjust the contrast. Now you can move from one to the other and see that there is a pretty good correspondence of the gyri, let's say here for example, and the sulci. It's not perfect, but there is a good correspondence. Okay, and one thing to observe is the ventricle size typically a good indication of the registration is when the ventricles match pretty well with each other. So the sizes here match really well. Not all the gyra and the sulci will match perfectly because not every subject have the same shape and the same gyra and sulci of every other one. So the template that you see here essentially matches, but it may have a bit of a shift in certain areas. So as you can see, this registration worked well. But if it didn't work well, one thing to check is whether this brain extraction worked properly. And for that, let me close all of this. What you can do, for example, is check, that the skull stripping have worked properly. So let's say you open again the anatomical image of our patient, and we want to know if the brain is extracted well and the skull is removed well. And to do that, you can just drag in this, actually the brain mask, sub-brain mask, load it as a segmentation, and you should see that this mask only follows the brain. Okay, now the other thing, let's see what else is in here. Here is the brain only image. So this is the image that actually is being used for the registration. Remember this, what I'm showing here is the raw anatomical image that you obtained from the scanner, and this is the processed one. So after bias correction, denoising. So let's see this as an additional image. Okay, obviously these are in template space, in the same space, because it's the same image. And the only difference that you should see is that one has the skull, the other doesn't. You can try to make sure that wherever the skull is removed, the brain is not removed. And the other thing that I want to show you is this denoising that actually is applied in LESYMAP. Let's make a little bit of... what you'd see, one of the differences is that we apply a bit of denoising here and everywhere in the image. It's a denoising that preserves actually the anatomical features, the gray matter, white matter, density and contrast, but it removes the noise that is in one of these. And one example could be seen here easily in the white matter. You could notice a little bit that this image, the native one, is a little noisier than the processed one. We apply kind of a soft denoising because some images might be perfectly clear and nice. They might be obtained from modern scanners. In 3T, others may be a little more noisy. Currently in LESYMAP, in the registered lesion to template function, I haven't put any option to choose how much denoising you want to apply. There is only a slight denoising applied, and that seemed to help as well to make the image clear. You can also see that here in the lesion area. Now, what else can you see here? When we perform registration, the last thing that you need to know is that the registration is performed with a mask. And that mask is this rag mask. We actually don't perform really the registration of the subject onto template. We do the opposite for technical reasons. Currently, we actually register the template on our subject. And the mask, the registration mask, is a mask that has the whole brain minus the lesion area. Let me show you that one. So this is what we have. Let me drag this rag mask in here, load this segmentation. The red parts are areas of the image that will take part in the registration, but the lesion area itself is not in there. And this is why you need a specific mask for the registration for lesion brains. You don't want this part to take part in the registration because you don't want to try to match this part onto the template, otherwise weird deformation will occur. Now, one thing to note is that this mask is slightly different from the brain extraction mask. The brain mask is this one. Now you can see that this mask goes everywhere in the brain. How do I zoom this? This mask goes everywhere in the brain, and it follows these edges perfectly. Actually, this is the mask that was used to extract this part. But if I load the other one, the registration mask, this is a bit wider, and it doesn't include the lesion area, but it includes a little bit of the area outside. So it includes a little bit of air, let's say, outside the brain. This is done on purpose because we want also this edge, this 0 to 1 changes of the image that are occurring at the edge of the brain to actually drive the registration, to help the registration pull the brain so that it matches as much as possible in shape the one from the template. So this is all you need to know. The other images here are the subject image in template space and the sublesion in template space, which we saw together. Now obviously beside these outputs here, which you saw because we defined output prefix here, you also have the output in the variable that we defined, and this is a list file, and you have all of these things in there. You can use these images, save some of these, etc., etc. That's all you need to know. Now you're ready to try your own registrations and run lesion to symptom mapping for all your subjects. Thank you.